Hello, everybody. Welcome back to another episode of Life, the Complete Story. As always, I am your host, joined by my lovely co-host, Alex.
Hi, everybody.
And today, we're continuing our talk in arthropods. We're going to be discussing the Chelicerates. So the Chelicerates are a grouping of more eight-legged, your arachnids, your sea spiders, your horseshoe crabs, and I believe that's it. If not, we'll cover it later on in the episode. So first, we'll start as we always do. Alex, what do we got in the news today?
So today's Nature in the News, we're talking about kind of a big thing that kind of goes in a lot of with when we talk about things like our amazing species and our most wanted, especially with our amazing species. Talking about sharks today and kind of how their diversity is depleted compared to the last, pretty much since the dinosaur age, 66 million years. They've been around much longer than that, but that was, I think, pretty much the
Peak.
I think that the absolute peak, and they kind of steadied out until around the last 10 millions of years. They have been declining until now, where they're at their lowest point. So this comes from Science Daily. It's an article from Swansea University. I don't have the authors up right
I
now.
think it's
I can
published through the
find
university.
Okay.
So
Yeah. Here we go. Jack A. Cooper, and Catalina Pimiento.
that's the reference that they use. But
Yeah.
this article it pretty much explains that throughout the past 65 million years, sharks were pretty much diverse. And it's functional diversity we're talking about, not genetic diversity and things like that. We're talking
Yeah.
about functional diversity. So this is where they fall in the ecosystem in terms of their role playing and their niches.
Yeah. So they kind of fit in where most other fish did, where you had small sharks that were like kind of just bottom feeders or filter feeders, to your varying levels up to your real big sharks that were apex predators. But now, as the article is saying, we're kind of losing that middle grouping. Most of our sharks now are either kind of that lower, like your nurse sharks. They're predatory, but they're kind of in that middle, lower range. They're like that early stage predator, or they go to your apex predators, your
salmon sharks, your great white sharks,
your reef sharks, tigers, things like that, lemons, and all those larger sharks that kind of fall more in that upper tier apex level of the ecosystem, which historically was not the case.
Right. So this article explains that most of the Cenozoic areas, so that's the Triassic, Jurassic, Cretaceous periods, they had about a relatively identical functional diversity throughout that entire period in terms of their ecological roles. And about 20 million years ago, we hit that peak during the Miocene. But then we kind of declined into like the two main roles. Like obviously you have your whale sharks and your basking sharks that are more filter feeders, but
They kind of fall in line more with whales than they do with sharks.
They don't really fit the shark niche comparatively. And we have your angel sharks, your lemon sharks or your nurse sharks that we talked about that are smallest, but we don't have that middle ground, along with a couple other niche sharks like your cookie cutters and things like that, your sawfish that don't really fit in any set niche. They have their own little niche. But if we go back the decades of millions, or the tens of millions of years, you can see a lot of sharks, and we'll talk about that more when we get into the class, like into the class that the fish are in. We'll talk more about since we have more of a false record for them, we'll talk more about the false record during that time. But for right now, all you need to know is that the past 100 million years or so, we'll say, sharks were all along the niche and ecosystem web of the ocean, and now they kind of fit in 2 or 3 main roles. They're not as diverse that way.
Yeah. Like even things like the megalodon, which was they're calling like an apex super predator. Like they were the ones that ruled the oceans. We don't have something quite like that anymore, and there's definitely no sharks that
Yeah,
are
at least
like
not in the
that.
fish dimension. Like there's
Yeah,
like killer whales
like
are the closest thing we have, but
yeah, but even they're not quite the size of the megalodon. That was, I mean, even the closest thing, or maybe like sperm whales, but their thing is they live so deep and they feed mostly on like giant squid and things like that.
right. But that's going to do it for today's Nature in the News. We'll move on into our regular lesson for the week. As we said, we're going to talk about the chelicerates. So we'll start with sea spiders. So a sea spider is a marine arthropod, not quite an arachnid, but also not quite its own thing. They fit in this chelicerate grouping. Thank you, appreciated.
Yes, sir.
They got some long legs in contrast to the body. You can kind of see in all these images the overall size can be like, some of these look like they're about dinner plate size in terms of overall diameter, but the actual body itself is no more than like an inch or two across.
Hmm. Yeah, the bodies themselves are fairly small, but they get a big leg span. Said some of them like less than a tenth of an inch, so
Yeah,
super tiny, and then up to almost 2.25 feet, which is like 70 centimeters.
yeah.
So quite large. I mean, can't quite see it in my
And
frame here. They get quite big.
they kind of work opposite of how we view most other marine life, where the more tropical species are larger, and the more Arctic cold water species are smaller so they can
Yeah,
retain their heat better. These ones work opposite. They're bigger in deeper waters and colder waters and smaller in the shallows. But there's about 1,300 known species. They are not true spiders, as I said earlier, and they might actually be more of a sister group to the other arthropods. They have 4 pairs of walking legs, but some have up to 6. So that doesn't fit the typical arachnid build where you have most spiders have 3 pairs of walking legs and a pair of feeding legs, as we'll talk about later. They take their gas exchange through their legs, so since they are completely marine, they have to do gas exchange through their skin, unlike other things that have gills, like the amphibians we'll talk about later on in the podcast. Their gas exchange takes through, I'd assume, slits in their legs.
yeah. That I think it's just through kind of those connecting segments where the
Yeah,
tissue gets thinner. Maybe
yeah,
I'm not sure, but I think it's kind of similar to the amphibians, where it's just a gas exchange,
right.
but without the lungs or gills that amphibians will have.
They have a proboscis to feed, unlike other arthropods that have, like how we talked about last week in the myriapods. They have like fangs and mandibles. These ones have just a straight proboscis, which is basically a retractable straw
It's the best
that
way to describe it.
sucks up bodily fluids from their prey. And their digestive system actually uh, extends into their leg, so that upper portion that would be like our quadricep area in humans, that's part of that is their digestive system as well. Since they don't have a lot of actual body size in most of its legs, they take advantage of that extra space with their digestive system.
Helps transport nutrients more efficiently. rather than just kind of have them float throughout the body and hope it makes it
Right.
to the legs.
They are dioecious. Is that the proper term, Alex?
Yes, would be dioecious.
They have dioecious. So they have two separate sexes, male and female, except for one species, and that species is a hermaphrodite species. And they have fossils dating all the way back to the Ordovician period. So, sorry for that. We were having some technical difficulties apparently. As I said, we got fossils that date back to the Ordovician period. So that's during probably right after the Cambrian, I believe.
I think so. I think it was very late
Because
Cambrian,
it
maybe
goes
early.
Cambrian, Ordovician, Carboniferous, Permian.
Give me 1 second. I should just start pulling this up at the beginning of each recording.
Yeah, we talk about it a lot,
we
but
talk about it so
well,
much. The
Ordovician period.
Ordovician is its own period after. It's right after the Cambrian.
Yes. Okay, so I was right.
Yeah.
But that really concludes our talk on sea spiders. There's not a whole lot to them. 1300 is rather small in terms of arthropods. But if you're really interested, the class of sea spiders is the Pycnogonida, named after a genus within the species.
Yeah, I believe so.
So with that, Alex, we'll bring it on into the second class of Chelicerates.
Yes, sir. So our next class of our Chelicerates are the Xiphosaura, which are much more commonly known as the horseshoe crabs. So I'll quit sharing here for a second. I'll let Tyler pull that up. So horseshoe crab, while he's pulling that up, they are not actually crabs. As you can tell, they are in their own group. Since here they are part of the Chelicerate grouping under the arthropods, so they are not under the crustaceans. So that's a big thing. The way their bodies are set up is a lot different than regular crustaceans. So the Xiphosaura, it means sword tail in Greek, I believe.
That sounds about right.
Yes, yeah, it is. It is Greek because of that telson at the back, that kind of long tail at the back. It's called a telson. That's where that name comes from. First appear in our fossil record in the late Ordovician, so that's long.
So after sea spiders?
Correct, yeah, a little bit after sea spiders. So it's still a very old group of organisms. However, there are only 4 living species of horseshoe crabs, but they've been seen throughout the fossil record. But their appearance really hasn't changed at all for hundreds of millions of years. So most people consider these living fossils. Actually, I mean they're similar to like the nautilus or like crocodilians. They haven't changed really at all over the span of the species' existence. So our modern species can actually get quite large, 60 centimeters or 24 inches in length. So they get pretty about the size of a serving platter. But most of the ancient species were much smaller, only about 1 to 3 centimeters. And their bodies are divided into kind of a front and back portion, as you can see in the picture here. That front is called the prosoma. It's got that kind of half, like semicircle carapace is what they call it, that dome portion. That's kind of like the head, sort of front of the body area. That's where all of us. They have 5 pairs of walking legs, and then a pair of pincer-like chelicerae, which I believe are forget what the Chelicerates are. If they're like they're little. Yeah, okay, those are like the front, little legs at the front near the mouth that they use to feed. And each of their legs actually have a small little pin. All but the last pair of legs have little pinchers on them as well, which they use to kind of tear up food as well as grab onto things as they move around on the surface of the ocean floor. But in the center of that prosoma is kind of like between where all the legs come together. There's the mouth, which has protected by like a lip-like structure called a labrum. So that exoskeleton I was talking about, that shell, for lack of a better term, it does consist of like a really tough cuticle. So it is very similar to the exoskeleton of crustaceans, but it's a little different. Doesn't have any of those like crystalline biominerals that we talk
Any of the
about.
carbonates or anything like that.
Exactly. Yeah, but they do have a. It's very similar to scorpions, actually, which are in they're chelicerates, but they're arachnids. Of the Xiphosaurians have kind of like on the outer layer of that cuticle, they have a layer of hyaline, which makes them actually UV fluorescent. So if you shine a black light on horseshoe crabs, they would glow.
Interesting.
Yeah. I don't know if you want to pick it up here for a
Yeah.
little bit, getting into some of the body composition.
Where are we at here?
I
We're
could
talking about, as you covered,
eyes.
they have 4 eyes. Oh, we didn't cover. They have 4 eyes.
Yeah.
Look at the caribous. They have 2 compound eyes on the sides, so you can kind of see them here. I have
Yeah.
my cursor hovering over top of it for our visual listeners. And then 2 median ocelli towards the front.
I
They're
think
kind of
that's
hard to
those
see.
those little white patches, kind of those lighter patches.
Oh, I see. Yes. So they're
I
not
think that's
exactly
what they are.
eyes per se, but they are receptive cells. The compound eyes are similar in structure to other arthropods, so they kind of look the same as insects, kind of shaped the same, made of the same stuff. But they're not in like that tetrahedral shape of like when you think of like a fly eyeball or something like that.
Yeah, they're real tightly packed together.
Yeah.
You get a whole bunch of them.
And really, they're really good for like movement detection. They're not really image capable. And then those ocelli we talked about, those white patches we believe up front, they are chemoreceptors, not so much eyeballs.
Yeah, that or the most they are is like light sensors.
Right. Moving on, we have the legs, and if you give me a second, I can pull up the image I have. Of the underside of horseshoe crab while we talk about the legs. So the first 4 pairs of legs ended pinchers, as you can kind of see, typical to like kind of smaller crab pinchers. Think of it like that. They're called. They also have spines kind of attached to them. Those are called nathabase on the inner surface. It's kind of hard to see in this image. I can't really make it out myself. Yeah. That's used to chew, in quotes, their food. Like Alex said, they tear it up, really. The 5th pair is the last pair of legs, and they don't have any type of pinchers or spines. They have like little brushes you can kind of see way back here, the little like fuzzies on the end. It's like a brush they use to clean their gills out. Because they are like burrowing creatures, they get a lot of mud and sand and other sediment on top of them that kind of clog up the gills. So those brushes are used to clean it.
Yeah.
And then behind that last pair of legs is the Chelaria, which is a lot smaller than other species. Not other species compared to the rest of the legs. They have a lot of hairs and spines, and they are vestigial limbs, believed to be absorbed of the first opisthesomal segment. The opisthosoma. Give me a second here to really.
It's kind of that second half when we were looking at.
Yeah,
the prosome is that front side. Yeah.
Where the spines are at, that is your opisthosoma. It is a mesosoma with flattened appendages, which I believe are these spines in itself.
Kind of what it looks like.
And a metasoma at the rear, which has no appendages. So, in the modern horseshoe crabs, the modern Chelicerates, it's all kind of fused together, whereas in ancient species, it was two separate areas. Moving on, the opisthosoma terminates into this long spine called the telson, as Alex alluded to earlier. It's very mobile in comparison to the rest of the animal.
Yeah.
And is used as like a balancing device. If it gets flipped upside down like this, it can use that telson to flip upright. Because this is where all the soft, gooey parts are that they want to protect. So the sooner they can get back to their shell upright, the better off they are.
Yeah, and they come to more shallow water to mate anyway, so they start getting impacted by the waves. You'll actually see them sometimes. Certain parts of the year on, I've seen them where they got washed ashore, and you can see them trying to flip over and kind of crawl back into the water. So it's a very useful thing to have when you got kind of short legs the way they do.
Right.
Yeah.
Next, we'll move into their circulatory systems. Chelicerates have very well-developed circulatory systems in comparison to other species in this classification of Chelicerates. They have a lot of arteries that send blood into a long heart that send it from the as well as to their body tissues. They have two longitudinal sinuses that kind of store blood, correct?
Yeah, I think that's kind of, it says the
it's like a makeshift aorta.
Yeah, they're near the gills. I think it's kind of more of a kind of help with the gills to diffuse oxygen.
I gotcha.
To like a larger amount of blood at once.
It's maybe. Like the gills absorb the oxygen through their processes and then push it through the sinuses to oxygenate the blood.
I think so. I'm not 100%.
Kind of like lungs, actually, huh?
Yeah.
Yeah, after being oxygenated, the blood flows into the body cavity and back to the heart. And unlike humans who use hemoglobin, these use hemocyanin, which we talked about a few weeks ago on the podcast. I don't remember where at.
Yeah, there's some organism we talked about.
I want to say it was within the mollusks, maybe within the cephalopods.
Maybe.
But we talked about it earlier. Where it's a lot better at. It's a lot better for marine organisms because it's not as efficient, but it's larger and can hold a lot more oxygen molecules per hemocyanin.
And it's something that's used a lot. So horseshoe crabs specifically are caught a lot, and actually their blood is used. They use that hemocyanin for a lot of medical processes because it is very good at, correct me if I'm wrong, it's very good in testing for bacterial infection, right? Or like bacterial contamination of medical supplies, and they use it for like with antibiotics and stuff, I think.
Yeah, it's very important in the medical world. One of the most expensive liquids.
Yeah.
Per gallon in the world.
Okay.
After like scorpion venom or something, I think.
I'm just trying to see if I can find something real quick.
While he does that, I will
Yeah.
talk about the reproduction of the Zephysaurians. As Alex said, they move to shallower water to mate. The male kind of mounts the female, gripping her with her first pair of legs. The female kind of digs out a depression in the sand to lay flat and lays her 200 to 300 eggs per clutch, where the male then covers them in his gametes. They separate, and the female buries the eggs. The eggs are very small, roughly 2-3 millimeters in length. In the egg, the embryo will go through 4 molts before it hatches. And after that, it kind of goes through some more molts. It starts like a trilobite. They call it the trilobite larva because it looks more like a trilobite than a horseshoe crab at the time. But as it goes through more and more molts, as it grows, it becomes into that horseshoe crab shape that we all know. And as Alex said at the beginning of, not the beginning of the lesson, but the beginning of this segment, there are 4 extant species. Those would be the mangrove horseshoe crab or the round-tailed horseshoe crab, found around Southeast Asia and those island countries, Indonesia, Bangladesh, the Philippines. There is the Indo-Pacific horseshoe crab, which is also found in South and Southeast Asia. The Chinese horseshoe crab, which is also known as the tri-spine horseshoe crab, which is found in north of that, more in China and Japan and Korea than those island nations, and the Atlantic horseshoe crab or the American horseshoe crab.
That's the one I've seen.
Yeah, we haven't been to Asia to go find the other ones yet.
Not yet.
Be cool though.
It would be very
and
cool.
With that, I'll shift it back over to Alex to go over our largest group of the day in the arachnids.
Sir. Yeah, so this one, you got to buckle up, folks. This one's going to be a moment. So our arachnids, many people are very familiar with these. These are your spiders, mites, scorpions, ticks, harvestmen, which are like the daddy long legs as we call them in America. Your pseudoscorpions, camel spiders, whip spiders, and vinegaroons, which I'm not 100% sure what those even are. They look very similar to spiders. So a very big group that fits a lot of very similar organisms. So all arachnids, the adults have 8 legs attached to what is a cephalothorax, which is like the front. They have a front portion and a rear portion of their body. That front portion is called the cephalothorax. That's where like the head, kind of what would be like the head, those functions, the mouth parts, the eyes, as well as where the legs attach is that front portion, and then they have the abdomen to the rear. So in some species, those front pair of legs serve more of a sensory function or kind of more of like a grabbing raptorial function, and then some species have separate appendages that are grown large enough they almost look like another set of legs. So all of our living species of arachnids are terrestrial, and they live mostly on land. There are some that live kind of in like on the edges of ponds, like it was the diving bell spider, kind of makes a little bubble of air that it can dive underwater and then come back and use that little bubble to breathe, but they're still more or less terrestrial. They kind of live on like that edge and hunt in the water, or some of that kind of edge of marine environments. I apologize for yawning. That edge of those marine environments. There are over 110,000 named species of arachnids, and of those, 51,000 are just spiders. So they are very big, widespread group of the arachnids. So as I said, pretty much all of them have 8 legs, unlike our adult insects that have 6. Many of them have chelicerae, which we talked about a little bit. They're kind of those a pair of kind of small little grabbing leg kind of appendages near the mouth that they use for eating as well as for defending themselves. In some organisms, they have kind of changed a little bit to be more like fangs in some of the spiders. They also kind of near those, they'll have what are called pedipalps, which they're kind of little tiny fake hand, feet sort of things. And a lot of them, they're used as another appendage for feeding. Some of them, they're large enough they help them move. The pincers of your scorpions and pseudoscorpions are actually those pedipalps that have grown large enough to become kind of its own appendage. And a lot of them use them for like reproduction, where what they'll do is the male arachnids will actually use the pedipalp to kind of gather a small little packet of sperm called a spermatophore, I believe is a little further down, and then they'll exchange that with the female to allow her to, spermatophore, to allow her to fertilize her eggs using that little package. But some organisms like the harvestmen and some mice actually do have regular sexual reproduction, but most do not. But a lot of arachnids have developed kind of complex courtship rituals to make sure that the females get that safe delivery of the sperm, as well as kind of just a way to determine what is best, like which what are their best options is I think the word I'm looking for. So some species, they're kind of raptorial, like the harvestmen. They kind of use them as like little grabbers, similar to how mantids do. So as we said, the body's broken up into 2 sections: the prosoma, that's cephalothorax, and then the epistostoma, or the abdomen. They use different things are placed in different sections depending on the species, like the ticks and the mites. Those sections, they're completely fused, and that's pretty much just that giant, especially in ticks, they use that primarily as just that big storage for the blood they consume. But in some species, as you can see in the picture there, that abdomen is segmented, and those are kind of that's the more primitive form, is that segmented or segmentation in the abdomen. But it kind of, there's varying degrees depending on the different groups. And as we just talked about with the horseshoe crabs, some species have a telson, like the scorpions, where they have that stinger that is unique to scorpions, and then things like the whip scorpions, which kind of have just a little flagella at the end, and then the spiders actually have the spinnerets, which are on the end of the abdomen, which is where they use to produce silk, which is something that is unique to spiders in the chelicerates, is that they produce silk. So, real quick, I just go through like pretty much all other arthropods. They do have that skeleton, but they actually arachnids are interesting that they have kind of an internal structure that's very similar to how a cartilage of like mammals and fish is, where the muscles attached, which allows them to kind of why their movement and things is a little different, but also how they are still able to function when they molt in certain ways. So yeah, if you want to continue real quick.
Yeah, no problem. So as we said, the endosternite is that cartilage-like tissue. Most arachnids lack any type of extensor muscles in their joints, so that's kind of why when you see a dead spider, he's kind of like condensed on himself, and all of that. They use like a hydraulic system almost to extend their limbs using their hemolyth, where solifuges and harvestmen extend their knees through the elasticity of their cuticle. And some have even extended to have 2 leg joints that also use that elastic recoil to kind of extend.
Cool.
So, moving on, there are some more important adaptations that they have to adapt to that terrestrial lifestyle, such as trachea.
Yeah.
The
Go
Good.
ahead. I was going to say, it seems as well, rather than having gills, a lot of them have what's called a book lung, where it basically, like the way their lung is, it folds in on itself. It looks almost like the way the pages of a book do, to allow for the gas exchange from the breathing tubes of the arachnids. So that's pretty cool. Pretty much vast majority of arachnids are carnivorous, or like the ticks and mites, they're parasitic, eating or consuming the blood of their hosts to, in a lot of cases, feed themselves to lay eggs. And then spiders, of course, use their silk, and in many cases, to spin webs to allow them to catch prey, which then they secrete venom from fangs that allow that they use to kill the prey and defend themselves. And a lot of those cases, that venom is also full of some digestive enzymes that allow the prey to start to be digested outside of the body, to which it can kind of just slurp up the digested portion of the prey. So, and then as well, just going through real quick here, a lot of them have multiple pairs of eyes, never more than 3 pairs usually. Some other than scorpions, which can have up to 5 pairs. They have both compound eyes, and then kind of more of just a simpler ocelli, which is more just like a light collecting eye. But some of these arachnids have more complex structures for their eyes, which is very interesting. And we already talked a lot about their reproduction. The only thing that may be different is that some scorpions and mites actually do give birth to live young, but it depends on the species. But these are things that have been found in the past, throughout the fossil record for hundreds of 100 million years. So, but some even up to 200 million years ago, and a lot of especially in amber, so that fossilized sap where those organisms were caught. So,
Right.
very cool.
As we said, there's they kind of go back a long ways. Some of the earliest species have been found in the Devonian and the Permian periods. They have found an amberite species in Myanmar that had spinnerets for silk making, but it also had a tail. Which is weird because
unique,
it's like
yeah.
This species is about 100 million years old, and a lot of the other species that have tails besides scorpions. So this is more like a spider species that has a
Yeah.
tail. But there's about a 200 million year gap between when this species was around and whenever those original tailed spiders were around.
Okay.
And you can classify the arachnids down even further into their orders, and that's typically how we do in taxonomic when we refer to groups of arachnids.
Okay.
So with that, I'll kick us off in our recurring segments here with our amazing species. And this week's amazing species is going to be the Poecilotheria metallica,
Okay.
also known as the peacock tarantula. So they are critically endangered. They are found in, let me zoom out on the map, India.
Okay.
Specifically the Nalamala Hills region and
Yeah,
the
it's like a
Nalamala Forest.
small area of very small area of India.
Yes. They are critically endangered, as I said, assessed way back in 2008, so we're probably going to need a new update within these coming years here. However, their original habitat is toasted, we'll say, to put it lightly. Literally, because they cut it for firewood. They are
Sheesh.
under intense pressure from other villages who use the forest for their own well-being.
Mm-hmm.
So where range is restricted to less than 100 kilometers squared in a single location, and the habitat quality continues to decline. So as I said, extant in India, in Jharkhand, West Bengal. They have a decreasing population trend in habitats of forest, whether that be artificial or natural forests. They're used in hunting and trapping. They kind of live on the plants that sometimes are gathered for like exotic plants, as well as the logging and destruction of their habitat. Not
Okay.
to mention any type of human interaction with war and things like that, whether it be civil unrest in India. They are pets on the national and international levels. And there's a wildlife sanctuary about 20 kilometers away from their known location, but it's unknown whether or not there are individuals in that area. But that's going to do it for I end our little segment here. I will try to get this image for you guys.
Yeah. So while he pulls up an image for you guys real quick, I'll move into my segment. There you go. There's our tarantula. Kind of
Little
a
bluish white.
fuzzy little guy, yeah.
Yeah, as most tarantulas are, they are kind of fuzzy, have those hairs that we said they use for as a sensory organ.
Okay. Yeah.
But go ahead, Alex. Lead us into our.
So the one I have today has kind of been a hot button topic in the United States lately, and it is the Joro spider. So it is a Trichinophila clavata. It is a spider native to Eastern Asia in the China, Japan, Korea, Taiwan area. However, it has been spreading across North America since the mid 2010s. And while venomous, it doesn't really bite humans, and the venom's not deadly anyway. So not something we need to be concerned about. But this is one of those things where kind of it was a hot button topic lately because a lot of folks were freaking out thinking that this was like the next big like how the spotted lanternfly is. It was going to come and all of a sudden take over, but it seems to be that seems to be less of the truth than what is actually occurring. So it's more of they kind of becoming more naturalized that many scientists think, rather than invasive. So that's something that we it'll take more time really before we are 100% sure if it's actually going to be a problem or not. So something kind of more today is more of it may not be invasive yet. Don't allow it some time, because these actually eat the invasive, the brown marmorated stink bug, which no other native species has been seen to eat. So maybe something they fill a niche that they don't really hurt anything, and just kind of fall in line with the native species. So then, lastly, for our last portion, we real quick we'll do our from the vault, because I may need to scoot here in a second. So
That's all
as well,
good.
yeah,
Yeah, we'll keep it quick. Today is Father's Day. We're recording this on Father's Day, so
yeah,
we're both kind of pushing to get this accomplished so we can get this out to you guys. But from the vault is going to be the sea scorpions. I'll pull up my image real quick. There we go. They're an extinct species of Chelicerate from about the Cambrian all the way up to the Permian. After the Permian, they kind of died out, weren't around during the Mesozoic period at all. So they're called sea scorpions because of that tail they have in the back. But really, they look more like an alien.
yeah. They're kind of freaky looking.
Although some species look relatively similar to horseshoe crabs. They had that more wider, domey looking face rather than this more aggressive insect-like head.
Yeah.
They had two different types of movement depending on the suborder. So the Stylinurians had appendages more like walking legs. They kind of crawled along the sea floor, whereas the Eurypterina were more swimmers.
Yeah.
So as you
Okay.
can see, this actually has a good image of both. So that Eurypterina is this big one trying to attack these fish up here. It's got that more paddle-like tail
hmm
and more fin-like appendages, whereas the Stylinurina are on the bottom here, more crawling along the floor.
Okay.
But I figured I'd share these because, as much as they're extinct, many of some of the modifications that we see in some of the more modern day organisms can be traced back to these sea scorpions. So they're like these gill tracts they have are compared to pseudotrachea and the isopods. Not exactly a chelicerate, but
Yeah.
similar enough.
Exactly.
Had
Very
their
cool.
molting stages like horseshoe crabs, but as I said, we're trying to keep this short. So
Yeah.
Alex got a boogie.
Yeah.
We'll keep this quick. Like us on our social media pages at Life Complete Story on Instagram, Life the Complete Story on Facebook. Subscribe on YouTube if you haven't already. Like the posts, leave a comment down below. Follow us on Spotify at Life the Complete Story. Email us at lifecompletstory@gmail.com for anything you want to see on this show. We're always open to new ideas. Maybe add a new segment if you guys want it. But that's all from me.
Yes, sir. Yep. And as we always say at the end of each episode, keep learning. You never know when you can learn something.
Learn something new every day. And with that,
Yes, sir.
I'm Tyler. That's Alex. We will see you next week to
Absolutely.
continue arthropods. We're not done
Yes.
quite yet.
No,
All
not
right.
at all.
Y'all have a good one.